All right. Okay. My name is Fardat. And from now, I want you to call me Freddie. Is that okay? Freddie, it's easier. Okay? Now, what that request did, what did it do? Do you have two teachers now? If you ask Freddie to teach you, will Fardat teach you? Yes, yes, right? If Fardat's absent, will Freddie teach you? No. No. Why?
Same person.
Because they're same people. What do you call Freddie in English? Freddie is Fardat's alias, right? You just gave me an alias. That's all. Please don't call me Freddie. I hate that. Like, okay, call me Fardat. Okay, okay. But I had to teach you that because we can create aliases in C++. In C++, you can give new names to already existing variables. It's not like you are creating two variables. It's the good old, same good old thing. And you just give it a new name. I know it sounds stupid, like why? It already has a name. Why do I give it another name? Well, you'll see it's going to have lots of good, amazing side effects. Are we ready? So, by the way, there's something that we don't teach. We teach it in OOP244NAA, but I'm going to tell you now. Just know it. There is a new way of initialization in C++. Okay, microphone. Who has a microphone? What is initialization? After you define the variable, so you can so pass the microphone. So what is it? So what is the difference between initialization and setting? Okay, my question is this. What is the difference between line 5 and 6 and 7? Thank you. And 6 and 7? No, you first created the variable. Let's use the right lingo. And then you set it. Okay, microphone. So let me explain. Line 5, it's called initialization. And it's an extremely important concept in object orientation. Initialization, it means setting at the moment of creation. Val will have no value other than 10 when it's coming to life. So val will get created with 10 in it. It will never have any other value. V1 will first have garbage, then that garbage is overwritten by 10. So V1 is set to 10, where val is initialized by 10. Do we understand this? That's going to be in your quiz. Okay? I will literally write that and see if you can tell me if that's initialization or that's setting, or what is this thing. I want to see if you can remember this. And this is an extremely important moment in object orientation. You need to understand what is initialization and what is setting. Do we understand this? Okay, next thing. So we know this is initialization. This is setting. I'm going a little slow, but I think it's going to pay off later on. So A, init, and setting. Let's go back. How functions are called. When you call a function, what happens? We need to understand this. What does it mean when what happens when a function is called? So when I actually write over here void foo, and in here I will say int val, and I write over here, I don't know, cout val is when you write over here integer see, I cannot put a name for it. Integer number. And I initialize it to 10, okay? If I say over here foo num, and if I say over here foo 100, what happens? Really, what happens behind the scene? This is how a function is called. When you write the function like that, call the function like that, compiler does this. Please pay attention. That's how foo is called. Do you understand? It means you don't pass values to functions. You initialize the arguments of a function by putting values in the function call. So when you say foo num, it literally means val will be initialized by num. It's not set. It will be initialized by num. Of course, num is an integer, so it makes a copy of num, right? When you pass 100, val will be initialized by 100. It's not that it's passed to it. Val will not exist without anything other than 100 in it when it comes to life. And each time the function is called, val comes to life. And because we said it's a function scope, when the function is over, val dies. So val comes to life with the value of num in it, lives in foo, dies. Second val is called, lives in foo and dies. Are we good with that? Do we understand that? So what I'm telling you is not some metaphoric thing. Literally, that's what happens. And you should act accordingly. So when a function is called, you should look at it, and in your brain, it should be, okay, this is going to be initialized with that and go. Right? Remember that. Are you good with this? Now, let's go back to Fardad and Freddy. So and this is not a CPP thing, it's C actually, but it's okay. Now, integer num set to 10, okay? Now I can create what I call an alias for num, and I will call it n. What do I do? To create an alias for any type, you put an ampersand in front of it. So integer reference n, if I do it like this, it's going to tell me it's an error. Why? Can I say Jack is an alias? Is that a complete statement for you? You're going to ask me alias for whom? Right? Yeah, I cannot tell you, this is an alias. What the heck? You have to tell me alias for what? Right? That's exactly what it means. Now, you understand when I say references must be initialized. You cannot set them. You cannot create a reference and then set it to something. They must be initialized. Do we understand this? Thank you. So I'm going to say, and you cannot initialize it to a value. I cannot say integer reference n equals to 10. That doesn't make sense. 10 doesn't have a name. You need to have a name to make it an alias. So now I can actually write over here num. What does this mean? It means the integer num has two names. As of line 7, you cannot tell which one is the real integer. Is n the integer and its alias is num, or num is the integer and the alias is n? That doesn't matter at all. And that compiler doesn't understand. Compiler, as of line 6, knows that there is one integer with two names, num and n. Are we okay with this? Yes. Who has the microphone? Give it to him. Go ahead. Ow. Okay, I'm sick, and I have a friend, another professor who teaches C++. His name is Freddie. When I'm sick, Freddie's going to come and teach you. Is it the same name as call me Freddie? There are two different variables. If I don't put the ampersand, I have two integers. And the second one is initialized with num. They have nothing to do with each other. If you set n to 25, nothing happens to n. But now in here, if I say, so in here I can say cout n, cout num. I run it, obviously they are both 10. What's important over here is that when I set num to 50 and I go cout n, now the n is 50 because they are the same thing. Do we understand? And now if I set n to something, num, again, please understand the fact that I have one integer with two names. Are we okay with this? Fantastic, Mr. Bombastic. Okay, so see. Next. You might find it boring that I'm typing like this. But the study shows the fact that I am typing, it prevents me to go fast. And the anticipation of you see me writing will help you commit what I'm saying into long-term memory. So appreciate it. Okay, it's not so, come on, type it already. Okay, be aware it's a good thing, actually. So, did you answer already? Microphone, please. Oh, you have it already. Wow. What is the output of line 15? Walk through. You can see it. I don't know. Can you see it now? Okay. What is the output of line 15? Only 15. Pardon me? 20. Pass. Is that correct? It's on. You don't need to turn it. Line 15. What is the output of line 15? Everybody think about it. 10? Why not 20? I'm not saying, you're right actually, he was wrong. You're right. Why it's 10 and not 20? Because, actually, give it to the next person. You answer, yeah, the gentleman. Why it's 10, not 20? Why it's 10, not 20? So let me run it first. So it's got to say 10 comes into the, well, let me just do like this. So in here we know this is I. I in foo. So when I run this, This is what we see. I in foo is 10. Adding 10 to I in foo is 20, right? When I come back over here, num remains 10. Why? It is initialized to 10. Actually, so when foo is called, we said this is how it's going to get called. So I is actually initialized to 10 because num is 10, right? Yes, okay. No, that's good. I want you to appreciate your C knowledge from IPC 144. You come to rescue. Go ahead. Because I didn't say how to fix it. I say why it's not working.
Oh, because she can't pass values with in a function without a pointer.
You can actually pass values without a pointer. You can pass values. You're passing a value. You cannot get values back without a pointer. Okay, so why is that again? It's passed by value, not by address. Okay, I just passed the value of num into, and the initialization proves it, right? So it says initialize I to num. I will get the value of num, that is 10. I becomes 10. With what I explained to you, I becomes 10. The lifetime of I is foo, and it dies. 20 dies in I, comes back here. Num got copied into I. It has nothing to do with num. Are we okay with this? Are we okay with this? All right. Now, if I want actually that to change using my C knowledge, I have to say integer pointer I, and I have to say target of I plus equal 10. And in here now, I have to actually pass the address of num, therefore integer pointer. Sorry, I'm changing the wrong file. Don't say. Yeah, and then in here, this is going to be integer pointer I is set to address of num. Okay? Now, if I do this, what's going to happen? I will be initialized by address of num, so I will be where num is. Then it comes over here, and it's going to say target of I has the value of whatever, and target of I has the value of whatever. Therefore, when I run this program, now num will actually change and becomes 20. Are we okay with this? Okay. Yes. Please don't sit over there anymore, because okay, and fit it from the other side so it's not visible. So that we don't need that. Is it better now? Okay. All right. So that's that. Are we okay with this? And you guys can see this, right? Okay. All right. Now, the next one, we'll go back to what we had before, which is passed by value. Now, take a look at this. I'm just going to do this. Look. Just pay attention. That's it. Done. Now let's walk through. What happens over here? Num is 10. Foo num is called, right? Reference I will be created for num. I becomes a new name for num. Now in here, I and num are the same. It's just a new name for num, right? Right? So when I add 10 to I am actually adding 10 to num. And done. ta-da, no more pointers. So that alias thing, it looks like a dumb thing, but when you use it with function, it does magic. You don't have to think about address of, target of, what do I, you just simply make it a new name. But we need to realize that when the function is called, it initializes reference. That's why I can have a reference in an argument. Because each argument of a function is initialized by the thing that is passed to it. Are we good? All right. And it can actually do crazy stuff. Let me show you some crazy stuff. Whoa, 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 whoa. So this one is going to be called EF pass by reference. Are we okay with this? Return I. Now this is going to bake your noodles. I want you to listen to it properly. And in here I'm going to say so what's happening here? When I say integer reference I, what does it mean? It means A is a new name for something else, right? When I say integer reference foo, what does it mean? It means the entire function is a name for a new thing. So I can do something crazy like this. I'm putting an assignment that writes out of a function. What the heck? How can I do that? I can. Because foo is designed to be a new name for anything. What is that? I. What was I? Num. So num has three names now. Num, I, and the foo itself. So now if I print num, it's going to be 400. Ta-da! Okay? Bear this in mind. It's going to come handy later. I know it's crazy now. But again, when you define something, a fact, in a programming language, it applies everywhere. And you can do crazy stuff with it that's going to come on handy soon. Soon, we'll do magic with that. For now, it's just, what the heck? Why? Yeah, really, why? But soon we'll find out. All right? So I'm going to call this EFG crazy reference. Just remember this. Okay, remember. So when the time comes, I'm going to say, I'm going to use crazy reference now. Then you're going to remember what I want to talk about. Are we okay? Are we okay? All right. Now that we have done this, we understand what references are. Now we're going to go back to IPC 144 because I know none of you know what pointers are. And I'll prove it to you. Okay? We'll go through it. Okay? Not prove it to you, but they just scared you from pointers. Like you think, did I talk about pointers? Did I bring the pointers up? Did I go through the? Because I used to teach IPC 144. I had this lecture for them to teach what pointers are. And now I'm teaching that in OOP244 and OOP345. Okay? Just to clear students' mind of what pointers are and bring you in peace with pointers. Scary thing about IPC 144 is the pointers, right? So pointers are difficult. Well, you'll see. In 2 seconds, we're going to go through it and we'll understand exactly what they are. So let me see if I can find my stuff. Yeah, it's here. Okay, so let me bring this over here. Do you remember what define statements were? Who has the microphone? Okay, do you remember what define statements were? in IPC 144? Pass it to the gentleman because he knows. Yeah, what is it define in C? You wrote hashtag define. Well, what does it do? Pardon me? Yeah, it talks to the compiler and tells the compiler what to do. You remember? Oh, yeah, they do. You didn't have define in IPC 144. Okay, so I'll try to explain well. Have you ever written an email and kept writing about somebody and says, he did this, he did that, and he this, that, and you find out, oh, the person is a she actually. Then you say, okay, search through all he's and change them all to she. And go through all her, his, and change them to her, right? Search and replace, that's what define is. Literally. Hashtag, it means you're talking to the compiler. That's not a C command. You're telling the compiler to do something before compilation. So when you say hashtag define this to that, it means look for this phrase and replace it with what comes after. So that's the define statement. Are we good with that? I'm doing something behind the scenes. So we don't need these. We know what references are. Okay, so those people who are over there on their cell phone, I'm going to bring a slide, and there's no way that I can bring it to the side. So if you want to bring your seat a little bit to the other side so you can see the slide, it would be nice. Let me actually copy all these things in today's section. Add existing item. Okay. So what I'm going to do now, let's say we want to design the pointers ourselves. Let's say we are people who designed the C language, and we want to design the pointers ourselves. First, we have to understand what is memory. Memory is an array, big array of bytes, characters in your computer. It starts, and each one of them has an index, right? Index 1, it means the first byte. Second one, it keeps going up to the money in your pocket, how much RAM you have in your computer, okay? So that's the amount of memory that you have. And I started from 0, 1, 2, 3, and I go up over here and say, let's just say this is the address. I only put the right 3 digits, okay? So essentially, that's your RAM. The index of these bytes is called an address. So when you're saying address of memory, it means the index number of the byte in your memory of your computer. Do we understand this? Do we understand this? Okay. So if you want to send something to someone or indirectly get something from someone, you need their address. That's what we have, right? So to send an email to this gentleman, I need his address. To get something from him, I need to send a request to his address so he can send something back to my address, and therefore we get it. Or I can hand it to him and he can give it to me, right, in person. So we want to design a variable whose job is to hold where stuff are in memory, and we are designing it together now. So When you write integer var in your program in C, your cell phone makes a sound. You have to make it quiet. Sorry, my bad. And now it doesn't recognize me. No? No. Oh, there you go. All right. So, when you say integer var, it puts your integer somewhere in memory and tags it with a name. What is the address of var? 108. Perfectly correct. Where something begins, that's its address. The fact that it's sitting on 4 bytes because it's an integer, it's not important. Okay? So the address of var is 108, right? If I want to put an integer after var, what's going to be its address? 112, right? Obviously, because an integer is 4 bytes. So we understand what addresses are, right? Are we okay with this? So we know what an address is. So if I create a double, obviously it's going to be 8 bytes because it's bigger, right? Where it's going to be in memory, we don't know. Compiler asks the operating system sets a place. We don't care. It's somewhere. That's all we know. So my dvar is at line 132, and if I want to add another double after that, it's going to be 140. Are we okay with this? So the size of double is 8, size of integer is 4. So I need something, a variable, to hold this 132 in it, to hold this 108 in it. I want that type of variable. Why? Because I want to be able to access the variables remotely. You know that. I want to design that. So to do that, what do I do? Oh, of course, when I set some variable, set the variable to something, it completely writes over all the bytes inside that thing. And if I set the double to something, it writes over all the stuff. We know that too, right? OK. So now I want to create that thing. First of all, the address always has the same size. It doesn't matter how big is the target. When you send an envelope to a government building that is 40 stories high, or send somebody to somebody's house who's a small little bungalow somewhere, the size of the envelope is the same. The target doesn't tell you what the address is, correct? Are we OK with this? Therefore, all I need over here for something to hold an integer. So let's say the name of the type is pointer, because its job is to point. And it's sitting somewhere in memory. So that pointer by itself is a variable that I hold something in it, right? Are we OK with this? Now I put some value in it, say 102. Essentially, it means I want to point to address 102. Obviously, I don't have anything in 102. That's garbage, right? If I actually use the pointer to go over there, it's going to stop me because it's not my memory. So it's a good idea to actually put 108 in it, so it's actually pointing to somewhere that that is mine, right? Problem is that the name of the variables never tell you what the address is. So for that, we need to create an operator to extract the address. So instead of actually writing 108, I have to create something called address of var. So I can say PTR is equal to address of var. Therefore, it's going to be 108, right? And doing that, now if I say target of PTR is certain value, I know target of PTR. Because I say target of, I mean not PTR, but its target. Therefore, I put a value in it, and the value is going to go in there. Are we OK with this? So how did I design work? I create a pointer. PTR is a variable, like an integer. But its job is to hold other things' address. And I say PTR is address of val. So I set the PTR itself to something, which happens to be the address of var. When I say target of PTR, depending on what I put on PTR, it puts the value to the target of PTR, not the PTR itself. Are we OK with this? That's all the pointers. Now, let's see what is the problem with this design. This design would have been nice. I could actually use it in a program in C. But let's see what's wrong with it. And of course, if I print PTR, printf, sorry, it was C. That's why we have printf. So if I say that, output be 2, 3, 4, 5. If I say print target of PTR, again, it's going to be 2, 3, 4, 5. If I say print unsigned integer PTR, it's going to actually show the address that that thing is sitting at. Are we OK with this? Anybody over here is lost? OK. Now let's see what the problem is with this thing. let's say I want to make that PTR to point to the double now, right? So I'll say PTR is address of dvar, right? And now it's actually putting 132 in it. Now if I want to say target of PTR is equal to this, how it's supposed to put it in there? How does it know what is the size of the target? Over here I put only 4 bytes. Now I'm putting 8. How does it know that it has actually 8 thingies? So our design is wrong, because PTR doesn't tell what is at the target. I cannot see what's in there. I cannot know what is the type of the thing that I'm pointing at. I know its address, but I don't know what it is. So this is wrong. I can't do this. For this, when I create the pointer, I need to actually mention what type of a pointer it is. So I have to say integer pointer PTR, which means the PTR is a pointer. It holds a number. But the target of that number is an integer. And therefore, when everything is set, life is beautiful. Now, when I create a double pointer, I can say double pointer dptr. It's still a pointer, but I know that this dptr's job is to point to a double. And when I put a value in there, it knows the target is 8 bytes, and it puts it over there, and life is beautiful. Are we OK with this? And then I do this, it shows. Are we OK with this? So essentially, I should be able to write something like integer num set to 10, right? Then I should be able to say integer pointer p, and I can say p is set to address of num, correct? Right? Oh, this address of is wrong. Right? And then I can say, for example, cout target of p and do something like that. OK? And I can actually say something. I can even do this. I can say, so target. So if I run this, obviously it's going to show me 10, right? And now I can actually come over here and do something like target of p is set to 1, 2, 3, 4, 5. Now if I print target, and now if I see out num, obviously, because target of p is num, what's going to get printed is 1, 2, 3, 4, 5. Are we OK with this? Right? So why didn't we use these instead of the crazy stuff that we are using? Because C people like to be cryptic. So what happens is that they said, I don't like to type long stuff. Instead of pointer, put an asterisk. So when you are actually writing integer pointer, don't write pointer, put an asterisk. Don't write double pointer, put an asterisk. So when the asterisk comes after that one, it actually belongs to that. And to get address of something, put an ampersand. Therefore, when I say address of the var, that's address of. And the same thing, yeah. OK? And for target of, damn, people use asterisk again. And that happened. OK? So how do we fix this? Target of a pointer are both presented by asterisk. We have to find out how to manage this. OK. When you look at an asterisk, life is beautiful. You're like, that's multiplication. OK? So when you look at it, life is beautiful, that's multiplication. When you look at it, say, what the heck? That means it's target of. When you look at it, it doesn't make sense. That's target of. As a unary, it comes before a variable, like target of A, asterisk A. When it comes after a type, it means pointer. So put it in context. If asterisk comes after a type, it means type pointer, like integer pointer p, double pointer ptr. Forget about struct because it's not C, but employee pointer eptr. Are we OK with this? If it comes in front of a variable as a unary operator, like -5, not b, plus c, something like that, that means what? Target of. A is equal to target of p. That means p is a pointer. Target of t is x. It means t is a pointer. A is equal to b multiplied by target of c. A is equal to target of m multiplied by c multiplied by c. If you say it right, you'll learn it. Never say asterisk A asterisk B. That's the worst thing you can do. Never, ever say that. Always say what it means. And it's going to sit crystal clear. Got it? Now, how the heck this thing worked? Why did I write this and it worked? The reason was this. I said anywhere you see target of, replace it with an asterisk. Anywhere you see address of, replace it with an ampersand. Anywhere you see pointer, replace it with an asterisk. And I included that at the beginning of my thing, but I've hidden it so you don't see it. Okay? So it's not magic. These pointers are simply variables. Don't give them extra credit, for heaven's sake. It's just a variable. Its job is to hold the address of something else. Nothing special is about it. When you put a pointer as an argument, it gets initialized with an address of something. So it points to it. And you put the asterisk beside it to get target of. That's all about it and nothing else. Do we understand that? Are we okay with that? Okay. So what's the difference? Why do we even have an integer pointer? Why didn't we use unsigned integer? Because that's essentially what it is, right? We have numbers, and they're unsigned. That's all it is. The difference is that when you add 1 to an unsigned integer, 1 will be added to it, right? But when you add 1 to an integer pointer, what should be added to it? 4. Because next integer is 4 bytes away. If you add 1 to a double pointer, 8 should be added to it. Why? Because it's 8 bytes later. And that's where pointers come from. Sorry, arrays come from. And that's where arrays come from. How? How? If I find the directory, I'll show it to you. We have 5 minutes. Don't rush me. OK. So we had the thing. We create the variable. We know that, right? And then we create a pointer. We can point to it. We understand all these, right? So now I have a pointer pointing to one variable. Are we OK with this? OK. And you can put values and all the good stuff with it, so we know all this. Well, when I say an array, what happens? When I say integer AR5, what happens? I actually have 5 integers created with the address of the beginning, right? That's not what happens, actually. In reality, what happened, and obviously, when I set an index, it set the index to something, right? Right? So when I say AR3 is this, it sets that one. But that's not what happens. In reality, when you say integer AR5, a constant integer pointer called AR is getting created somewhere. It's a pointer. And then 5 integers somewhere else. And then the address of the beginning is put in there. So when you say, if I say target of AR, that actually means AR0. You can actually write this. And it actually sets the first argument. And when you say AR2, that's where the index comes from. When you say AR2, it means add 2 to AR. 2 to AR means 2 integers. Means what? 8. It means it jumps 8 bytes, and this becomes next. That's why you write 2 for a third element. And that's why you write 0 for the first element. It means from the address AI goes 0 integers further. That means the first one. And you said it. That's why you can actually write something like this. Target of AR plus 2 is 555. These two are identical. It doesn't make any difference. And you do this, that's going to be 555. So arrays in C are essentially a pointer pointing to a bunch of stuff instead of one. So if you have one variable with a pointer, one variable with a pointer, instead of target of, you can actually say pointer index 0. It's the same. They are identical. No difference. And knowing that, going through all these, the next day you are coming in, we're going to learn, the next day you are coming in, we are going to learn that when you create integer A5 like this, the entire array is inside your executable because it's happening at compile time. When you actually write integer A5, compiler compiles it, we need 5 integers, puts the 5 integers inside your executable. So when you run your program, the executable comes to memory, and with it, the array. So if you make an array of 1,000, your executable becomes bigger. That's problematic. What if you have 5 billion information? So I need to somehow take over this array creation. That's where dynamic memory allocation comes in. And this is the introduction for it. We'll talk about it the next day. So instead of doing that, come on, I can actually say integer pointer A is set to new integer 5. This doesn't happen at compile time. This happens at runtime when the program gets executed. So what happens, this is a C course, not C++. I mean, sorry, this is 244, not 344. They have a class with me in 3 minutes. 345. All right? So I can say, give me 5 new integers. So when this is running, and it doesn't have to be initialization. You can create the pointer and call that whenever you want. At that moment, your program asks operating system, hey, I want 5 integers. And it gives you from the shared memory that all application uses. So your executable remains small. Big, big catch for it. Because you created it, you need to delete it. If you don't, that array will remain in memory forever. What does it mean forever? In computer science, it means until you reboot your computer. Have you ever had the problem that your connection, your Wi-Fi doesn't work at home, and you call Rogers and say, unplug it, wait for 15 minutes and plug it back in? It's because their program has memory leak. This is called memory leak. Somewhere they allocated the thing, they forgot to deallocate. As the connections happens over time, memory leak becomes bigger and bigger and bigger until the memory of your modem is full. And it doesn't now function anymore. So you unplug it, you reboot it, you put it back in. And then they created new firmware for it. So that leak is taken away. So if you don't delete it, you're going to have leak. We're going to put specific rules and regulations like Army. Go 1, 2, 3. You have to do it that way. When I tell you, when you allocate memory, first you do this, then you do that, then you do that. If you follow those, you're not going to have memory leak. If you just program, then you're going to have crashes, and one of the most difficult debugging is memory leaks. See you next time. Go through all these things and be ready. We have intense things to talk about the next day you're coming in. Have a beautiful day.
Thank you.
Thank you. And when you go out, please tell to those people to come in. Have a beautiful one.
Sir, can I use any computer in Seneca to pass my Ultra 1, or just the computers here?
When you get an extension, automatically it doesn't ask you to be here. You can do it anywhere. When the time is passed, you can submit from anywhere until midnight. But if you ask for an extension, then you get an extension. You can submit it from anywhere.
Okay, thank you.
No problem.
Is the reflection due in a couple days? You have to do it at home, right? Reflection for workshop 1?
Yes. You have to do a dash do to see exactly when. Write a dash do after.
At home, right?
Yes, you can do it at home anywhere. Only the lab is due from here, okay? All right.
Thank you, Professor.
Have a beautiful day, student, professor. Huh? No, I did not. It's recording. Thank you.